All right, welcome back everybody. Welcome to our last session of the day. Our next speaker is Arthur Hebecker from Heidelberg, telling us about Cobordism, bubbles of anything, and the boundary proposal. Please.
Okay, thank you very much. Thank you very much in particular Timo, Alexander and Craig and all their younger friends for this beautiful meeting and for inviting me. Okay, so my topic today is Cobordism, bubbles of anything, and the boundary proposal. And the plan is as follows. I will start by discussing Cobordism and... okay. Oh, much better. Sorry. Okay, so once again, thank you very much, Timo, Craig. Okay, so I hope you heard that. Cobordism and end-of-the-world brains is my main topic, and the beginning of the talk will be developing a 4D EFT view of the story, such that it's more suitable for cosmological applications. And then I will turn to the more stringy part, and in that part I will explicitly construct an end-of-the-world brain for, in my view as a string phenomenologist, a very important part of the landscape, namely the type 2B flux landscape. And I will then briefly try to argue why I think that's actually cosmologically important, and time permitting, I will discuss a very recent, somewhat exotic proposal, which we call the boundary proposal. All right, so let's start. So in spite of all the well-known issues of KKLT and LVS and the problems with getting the sitter, more generally, let me, for the purpose of the talk, be optimistic in that some realistic string landscape, which does not need to be the sitter at all, it's not necessary, will eventually exist and come out. And if such a landscape exists, then of course, the question of how landscape vacua are created or decay, one of the old questions of string phenomenology, remains important. And so now comes in the Cobordism conjecture, because by the Cobordism conjecture we expect that end-of-the-world brains are ubiquitous. They are also there for all our possible 4D landscape vacua, and they will contribute to the creation of and decay of landscape vacua, and hence their effective theory is important for us to study, to make predictions. All right, so before I come to anything more complicated, let me remind you of the kind of key paradigmatic example here, which is Witten's bubble of nothing. So you have a S1 compactification from 5D to 4D, or in the picture from 3D to 2D. So you have an S1 over every point, over every of these great points, and the S1 shrinks at a certain locus. This locus is a circle, so here inside the circle you have a hole, the bubble of nothing. That's the Euclidean view. The Lorentzian perspective is that you take this, half of this as an instanton, and here at this point you glue this off-shell Euclidean region to the Lorentzian region where this bubble of nothing expands and eats up space-time. Okay, that's probably well known. And in principle, you can have the inverse. You can have a disk, and the S1 shrinks at the boundary, and over the disk you have your compactification, and outside the disk there's nothing. And now the Lorentzian view is that you have this half ball, and from this line where you go on shell, you have an expanding spatial region, creation of nothing, creation from nothing, or as we think is maybe a better slogan is bubbles of nothing and bubbles of something, together explaining my title bubbles of anything. Okay, so now more technically, end-of-the-world brains of course are an old story. They have been studied a long time ago, and more recently in the context of the Cobordism conjecture, or even slightly before, have become again very popular. Let me emphasize the papers by Garcia Echevarria and by Blumenhagen, to which I'll come back later in more detail. And let me now start more technically. And first, I will still discuss the previous very simple example of Witten's bubble of nothing. Namely, the metric is given here. So there is the S1 for n equals 1, but we will also talk about more general cases. This is a compact metric over this shaded region. And then there is a radial coordinate drawn here in red, dr, and then there is a 3 sphere in the picture, of course, a 1 sphere here around, and the function, the field beta, sorry, the field phi, parameterizes, it's a dilaton parameterizing the size of the extra dimension, and the prefactor has been extracted here such that this is the actual 4D Einstein frame metric. So it's a very simple explicit metric given here and an explicit solution, which is just the famous Witten bubble of nothing solution. So here is again explicitly the radius of the S1 in terms of this field phi. So now there's one crucial point. As I go to the boundary where the bubble of nothing sits, i.e. r to 0, phi goes to minus infinity, and this circle actually has 0 volume as measured in this 4D Einstein frame metric. And that presents a problem which I will now explain in more detail. So the 4D description of the brane at r equals 0 is problematic because, as again here, the radius of the compact space goes to 0. So look at the picture, and hence the 5D Planck mass goes to 0. And that means all the length scales at the end of the world brane, in particular the bubble radius, vanish in the 4D effective theory. So therefore, the 4D calculation in terms of end of the world brane tension, I mean a naive 4D view of a boundary, actually is not obviously possible or looks impossible. And so our first goal is to resolve this issue in a universally applicable way. And here's a key idea. So in many cases, in particular, if I don't shrink in S1, but some complicated space, maybe even a Calabi-Yau, the tip of this Witten cigar, if you wish, will always be either singular or even carry a defect. And so we may, from the very beginning, just maybe as a regulator or also physically, assign a defect to this point. So there will be some object sitting here, which I can take to 0 size later on if I wish. All right, so now the picture is this one. I declare this defect has some small size, and around the defect there is a deficit angle which characterizes its tension. That is just simple general relativity. The deficit angle defined in this way, where r is the radius and x is the proper coordinate, the proper length going along the cigar. Then this deficit angle is the tension. And now if I give you the size of the defect, the deficit angle, and the kk scale, i.e. the compactification radius at infinity, the full solution is determined. I'm not going through it. This is well known by some of the papers I cited. The solution is determined. And of course, in the limit that eta goes to 0, I remove the defect, theta goes to 0, Witten's geometry is recovered. Crucially, if I keep the cutoff, I have a non-singular 4D description. And in many cases, I may even keep the cutoff for physical reasons. So what is more, with this description, I actually can derive my solution from a simple 4D action, namely Einstein gravity, 4D Einstein gravity, the scalar which parameterizes the size of the extra dimension. A potential could be there, in our Witten case is not there, and the standard Gibbons-Hawking-Young boundary action with extrinsic curvature and the defect tension. And now crucially, this defect tension has two pieces. It has a 1 which is there even if there is no deficit angle, i.e. a smooth Witten cigar case, and the theta which can correct that. And the whole thing is divergent if I take the defect size to 0. So you can view it as a regulated divergence with this factor, which is an artifact of using the 4D Einstein frame, which in a way is the inappropriate description exactly at the boundary. All right. So having this, we can now calculate in a standard way the decay rate for the bubble of nothing by subtracting from the instanton, which is drawn here, the 4D vacuum. The exponent in the decay rate is given here. For theta equals 0, of course, reproduces Witten's result. And In fact, I can go one step further in my approach to do that for the EFT. At the moment, I have, let me go back, no, let me show here. At the moment, I have a 4D EFT description where I have this 4D theory with a scalar everywhere, and just at the boundary, very thin line, I have fitting this defect. But of course, I can say that I count the whole region where the geometry shrinks as part of my boundary. Then I have an effective boundary and an effective 4D tension where now I do purely 4D effective theory. So this is now a view which is even more bird's eye, in the sense that the region where the scalar field varies is also part of the tension. I have an exponent purely in terms of tension and the 4D Planck mass, and the 4D tension is calculated here for the case of Witten or including a defect. And now one can go ahead and apply this much more generally. One can think that the shrinking space could be anything, could be a 2-sphere, a 3-sphere, a Calabi-Yau, something else, as long as I have a solution, of course. And here is a selection of these different situations you can imagine. So if you shrink an S1, it can shrink smoothly over the defect. But if you shrink, say, some Riemann surface, you have to have a defect because there will be no smooth Cobordism, maybe. Or you can have some singular orientifold type case, as discussed in this particular case in this paper. The radius can shrink, can grow, so this would be a negative deficit angle if you wish. There are many options which all fall into this description in this 4D EFT with a defect at the boundary and a field. So I fix the field value at the boundary and as gradient if you wish, and then I can do everything in 4D EFT. All right. So now a key point comes in, namely, as I said, deficit angle and defect size determine the bubble of nothing. But for sufficiently high defect tension, the end of the world brane tension can become positive. So the defect tension, which is some microscopic information at the singularity, affects the end of the world brane tension and can lead to a positive effective end of the world brane tension. So basically, instead of this instanton, I now have this instanton. The decay process becomes a creation process. So Witten bubble of nothing does not allow that. It's only a bubble of nothing. But you can, in principle, analogously think of actual creation processes, i.e. bubbles of something. I forgot, apologies very much to, of course, this goes back to Hawking Turok, and there's a long story by Bianco Pilado. I mean, there's a number of references. I mean, the bubbles of something have been studied before. There's a set of old references here. Should have been there. Okay, so now let's go for an explicit example of this in the type 2B landscape. So it will be, in fact, embarrassingly simple, but I think it's still important to consider. Namely, start on, in fact, let me start not type 2B, let me start on the type 2A side. So I have here, this circle represents my Calabi-Yau, and this line represents my 4D space. The direction transfers to the brane, and at some point, I can just cut off by putting an O8, a fully saturated O8 plane on the type 2A Calabi-Yau, right? I mean, this will just end space. This object wraps the whole Calabi-Yau and wraps 3 of our 4 dimensions, so it's an end-of-the-world brane, space-time ends. Now, by T-duality, or mirror symmetry, this can immediately be taken over to type 2B. Of the O8, I produce now O5 planes. And so this is now type 2B Calabi-Yau ending in this way. On O5 planes, the existence of which I can, of course, also derive by orientifolding type 2B, but I know by mirror symmetry. So, as I said already, alternatively, I can get this directly by orientifolding my type 2B Calabi-Yau. Namely, I have to combine an anti-holomorphic involution with my Calabi-Yau, where so X3 is my non-compact coordinate, and there's an anti-holomorphic involution on the Calabi-Yau, and the inversion of this spectral coordinate transfers to the brane X3. So it's very simple construction. Now, of course, if I want to do that more realistically, I also want to be my space not to be a Calabi-Yau, but to be a Calabi-Yau identifold. So let me say I have O7, O3 planes on the Calabi-Yau itself, independently of the end-of-the-world brane. So in this case, let me first consider purely O3. Then the picture will be as follows. I have here in the bulk, you have to imagine this way going to infinity, a Calabi-Yau with an identifolding with localized objects, for example, O3s. I draw them as points here, and going along this non-compact x3 direction, they become lines. Then at some point, I have my end-of-the-world identifolding. Then I have here O5, D5. These points here represent 3 cycles in the Calabi-Yau, okay? And the O3 can in principle completely, or generically will completely miss the singularity, so the whole thing will not have any singularities except the O3 planes on the Calabi-Yau and the O5, D5, which are defining the location of the end-of-the-world brane. That's an explicit geometry. If O7s are also present, then those will unavoidably intersect these O5s at the end of the world. But nevertheless, in fact, in both cases, either O3 or O3, O7, we show, and I will not explain it now in the appendix of the paper, that the situation is such that you still preserve 3D n equals 1 SUSY. 3D because the maximal space-time symmetry you can still expect is of course that of the brane. It's only 3-dimensional, so SUSY is reduced from 4D to 3D, but it's still present. So n equals 1, 3D. So, and at this level of precision, which I'm now discussing, space-time is SUSY-Minkowski, and the end of the world brane is 0 tension. So there is no bubble of either type. If there is 0 tension, then basically you have a half space cut off by a flat brane, nothing else happens, okay? But of course, this is not the truth, or at least not the case we're interested in. Nevertheless, let me maybe, for time reasons, flash this only briefly, just for somebody who wants to think carefully about the geometry. Here is a simple T6 by Z2 models with all the features I drawn here. Of course, I can't draw 6 torus, so I drew a S1, but you can check later. Okay, so back to the generic Calabi-Yau case. I mean, I'm explaining in simple torus language, but there's no problem with doing all this on the Calabi-Yau. So really, the 4D bulk will, of course, not really be SUSY-Minkowski, but it will be SUSY ADS or SUSY runaway. Why? Because I have only, due to the antifolding, I have only n equals 1 supersymmetry. So corrections will in any way come in. I mean, even if I fine-tune, or even if I create a model where W0 is 0, there will still be instantons, so somehow I would not expect this to remain Minkowski. So now we have not studied this. This is kind of a question to maybe the audience for further discussion. What we have studied is the surviving 3D n equals 1 SUSY, which we know of, should probably ensure that the end of the world brane will receive matching corrections such that it is stationary in the corrected geometry. So this is the expectation, not proven, that once we switch on corrections in this region and go to either ADS or SUSY runaway, this will also have corrections, and the brane will still be static in the sense like, for those who know, the UV brane or IR brane of a Randall-Sundrum model are static in a situation where the bulk is ADS. However, it appears that detuned, i.e. non-stationary SUSY end of the world branes are also possible, at least according to this paper by Gabelayev. So this is completely unclear to me. I don't know how to do the calculation. We are struggling with this at the moment to understand better what the actual tension will be. So the preliminary result is only something very vague, namely that the fully corrected tension will be something in between the two extreme cases of a UV or IR brane of a ADS-based model, which is expected here after I switch on corrections. So now let me go even further. So what we really care about is, of course, a bulk vacuum with a flux, generic non-SUSY flux, like in GKP, for example. Okay. So now, of course, in parallel to the O5, D5 and to the world brane, we must add D5 and S5 domain walls to remove the flux. So I remind you, in my naive picture, I'm removing dimensions, so these points are 3 cycles, so there's further brane trapping 3 cycles. Here is the actual flux background. So I approach the end of the world, I remove the flux, then I orientifold in the way described. This is the end of the world brane. This whole thing is the effective end of the world brane of the real, in quotes, if you believe in that, type 2B string landscape. And reliably determining the total effective tension of this is a key outstanding task, which unfortunately I have nothing more to say at the moment except speculations. All right, so and once we know this tension, we can calculate decay rates or bubble of something creation rates, if you think of the universe emerging from nothing a la Hartle-Hawking. And here the thing is clear, there's a certain suppression by the action. Here, as many of you probably know, there is this long-standing debate about the proper sign following Hartle-Hawking or Linde-Vilenkin. Let me only point out that if the Linde-Vilenkin sign choice is the right one, then actually the bubble of something, i.e. the creation with the boundary, would dominate the Hartle-Hawking creation process. So it actually has a chance to be the dominant creation process of the universe from nothing if you take these, if the science choice story is resolved in that way. Okay, so now 2 brief slides motivating why I think this is important. So we all have heard about the measure problem and the fact that in a global multiverse where you have bubbles and bubbles and bubbles, there's a problem of counting. You have somehow to cut off at infinity to be able to count. Then you take this, the limit of the surface going to infinity. Then you depend on how you take this limit. It's a regularization process. It's a horrible story, unresolved. So now, based on the cosmological central dogma, which basically we want to argue for a quantum mechanical, more precise measure, and the underlying statement, the cosmological central dogma, simply says that you should not think of global de Sitter in this context, but you should think of de Sitter space being a finite system with a very large dimensionality in the Hilbert space, but only finite counted by the degrees of freedom on the horizon, just like a black hole, just inverse. So now, in this perspective, eternal inflation turns into an infinite series of transitions between different subspaces. So I've tried to draw a cartoon of this. So if this whole thing is the expanding de Sitter space, you only watch the static patch, you only watch the region inside your horizon, and in that region, you witness a transition because something nucleates and expands here, and then another transition, and basically it's a quantum mechanical system tunneling back and forth between different vacua, which are just finite Hilbert spaces. So this type of measure can be described by a Wheeler-DeWitt equation with a source, and the source term is of course sensitive to the bubble of something. It's also sensitive to Hartle-Hawking creation processes. So if you take this approach to the multiverse, then actually the probability with which you create something is absolutely key to make any prediction. Because you're not sensitive anymore, you dismiss the possibly also, or the possibly present attractor at the infinity of global de Sitter space. All right, so let me summarize and use the last 2 slides to explain a new idea. So there are 3 possibilities. The standard one, half sphere expanding compact universe. That's famously Hartle-Hawking. As I argued, one of the processes, bubble of nothing, bubble of something, bubble of something case, is this one. So you have here not a sphere, but a half sphere, a ball, if you wish, with a boundary in the Euclidean region, and then it expands. Here is the actual instanton solution, which is the Euclidean solution to gravity. Now, once you take these 2 things and discuss their relative importance and their cosmological influence, as I just did, you can have a crazy new idea. Namely, you say, okay, this is also a solution. If the tension and the cosmological constant here have the right relation, then these 2 cutouts, you can have only one of them or 2, it's equal, it's local, gravity is a local story, both are solutions. This is a Euclidean solution. You can cut it here rather than this way and glue it to an expanding Lorentzian region. That means that the universe is now created from a boundary. So the past in the Euclidean region is an actual boundary. It's, if you wish, the end of the world version of an S-brane. It's a proper a space-like end-of-the-world boundary, constructed macroscopically the same way I described before. Then you go to Lorentz, and then it expands. And very interestingly, for the Linde-Vilenkin sign choice and a small end-of-the-world brane tension, this boundary process, which we call, that's why we call it the boundary process, so this process is actually the most dominant one of the three. So there's a chance that this is actually not just a nice observation, but actually has cosmological significance. So finally, one may also consider the creation not as of a sphere, but of a torus. And there, one in fact arrives at a puzzle, which may call into doubt what I said before, and I think it's an interesting question to be discussed and resolved. Namely, if there exist zero tension end-of-the-world branes, like in type 2a or 8 plus 48 branes, then you have a possible creation process of a torus without any offshore region, and hence with no action cost at all. You simply have, I mean, you should draw a 6 torus here, but I draw an S1. Here is the end of the world. Here the universe starts. By the rules of Euclidean quantum gravity, that seems to be a creation process of the universe, believe it or not. Okay. So that, I think, brings me to the point where I should stop. Let me briefly summarize. So, 2 technical points. We have developed a universally applicable 4D EFT approach for end-of-the-world branes associated with a shrinking compact space. I hope, at least we think, for us it was useful to think that way and to use this to calculate cosmological implications. Second, we have proposed a simple explicit geometry suitable as an end-of-the-world brane for the actual type 2b landscape. The precise tension of this object is, I think, a key research goal, and it's needed to quantify whether the bubble of something process, for example, is actually relevant for cosmology. So, as a side remark, there are measures where this type of thing is really crucial. There are also other measures where this is not important, but it has a chance to be of actual relevance. And finally, in this context, I very briefly explained to you at the end a new idea, namely a creation process using a purely space-like end-of-the-world brane, which of course has to be seen whether we can establish it in string theory. We call this a boundary proposal. I think it's a very interesting thing to consider, at least as a theoretical model, as a thought experiment. Thank you very much.